let's move on to something that I'm actually more excited about today, which is to do this paper together with you, which is this SAJC paper. The solution is being shared with you, okay? So, but my suggestion now is to try to do this paper, like for you to try to do this paper together with me. And I don't want you to do it at any other pace other than my pace. That means I want you to try to process this question together with me. I want you to try to link whatever that is asked by the question to stuff that we have discussed before together with me. I want to do it as a recap, not just simply as a practice. Because the best way to do revision is not to plan so that you can revise it and then sit for an exam. The best way to do revision, you will realize, is to plan to revise it a few times before you sit for the exam. Go through the revision a few rounds before you sit for an exam. And that's what we are trying to do in this holiday, this June holiday, because we have already finished one full round of revision through, and I've shared with you all my conquests. By the way, my conquests are very good. Please make good use of them. Use my conquests, use my outline, okay? I'm very sure you're going to get better and better if you keep using them. So I'm going to be referring once in a while back to the outline, once in a while back to the conquest that we have been discussing to go through this paper. And I am also believing that you guys... Question number 3 here says, part A. Given that the graph of y is equal to fmx is equal to the graph of y is equal to fx, they are identical for all real values of x. M is a non-zero real number. State the possible equation for fx. So from fx to fm minus x, I know it is going to be a scaling by a factor of 1 over m parallel to the x-axis. Scaling by a factor of 1 over m parallel to the x-axis. As we talk about it, as we try to recall, if you have any misunderstanding or if you have not understood it properly the last time when we were doing our revision, can you try to take note? Or if you feel the need to ask me now, just ask me now. Or even if you ask me now and I cannot answer you yet, at least you give me a chance to know that you don't know, okay? So please, let's try to be... Oh, Shijie, you're going to get your jab in 2 days' time. 2 days' time as in like Tuesday, okay? But I heard my student, I heard some of my students is getting a jab today. Like I was surprised though, like even on the holiday, on the weekend, they are going to be having the vaccination. So anyway, this is going to be a scaling by a factor of 1 over m parallel to the x-axis. This question is very, very good. Although it is just a 1-mark question, but it is very, very good. Because it requires you to imagine. It requires students to have some kind of experience. Right? I don't think it is very difficult, but please take note that you are supposed to be doing this question you are supposed to be doing questions in the exam. And I believe that when this appears in the exam, it will appear more difficult to some people. So if it is a scaling parallel to the x-axis, can we have fx to be something that is a little slanted? Anything that is a little bit more slanted will be scaled, correct? Which means that for part 1, I want it to be with as little slant as possible. Geometrically, if it can be just super straight, it is the best. Super straight. That means I want something that is of a straight line. Maybe just y is equal to 3 or y is equal to 5, y is equal to minus 7. Any straight line should be able to answer this question because this question asks for a possible function for fx. So y is, I shouldn't write y. I should say fx because they ask for a function for fx. So a possible function for fx will be fx is equal to 3, maybe. So I'm drawing a horizontal line. And when it is scaled by 1 over m parallel to the x-axis, this horizontal line will remain exactly the same. This is part A. Then B. B, we are given a graph of y is equal to fx. It's going to undergo 4 transformation. And we are going to be getting a resulting curve. We are getting a resulting equation. The resulting equation is this. We have the best strategy. And you'll be foolish if we have the best strategy but we don't use it and we try to formulate it ourselves. What do I mean by formulating it ourselves? I was telling you that what a lot of people try to do for this particular kind of question is to try to reverse the process. Because they describe to you how one transformation gets to another. So what you can do is, since you have the resulting equation, you can try to reverse back to get the original graph. I was telling you that this is possible. But this is not going to give you the best possible experience during your exam. Because in exam, I want to try something that is more familiar to me. I don't want to try to walk backwards because I don't walk backwards all the time. So where is the process? The process is in our conquest. Let me show you where it is in case you have forgotten. If you have it and you cannot remember where it is, please just flip to that page at least. Okay, flip to that page and convince yourself that, hey, it is in my conquest. So in a conquest, under the part on graphical transformation, we have one such question, which is here, this PJC 2011 question. So this fx undergoes this field transformation and we have a resulting curve. And for this resulting curve, we are supposed to work backwards, but we formulated a strategy so that I can continue transforming forward. So we have an example here. If you cannot remember, please come back and look at this example. And I'm going to make use of exactly the same strategy to do this particular question. Let's try. So according to what this question says, this is what we are going to be experiencing. According to what the question says, fx is going to undergo the first transformation, A. A is going to be a translation of 2 units in the negative x direction. Transformation of 2 units in the negative x direction. So it's fx plus 2. And please remember, from one step to another step, it is not taking the whatever that is in the bracket plus 2. You are replacing x. You're replacing x. Which means that in the next step, B, scaling parallel to the x-axis by a factor of 1 over 3. You are replacing x. So scaling by a factor of 1 over 3 means you are going to replace x by 3x, then plus 2. The plus 2 is not going to be touched. You are just supposed to be replacing x by another expression. In this case, it is 3x. Because you are scaling it by a factor of 1 over 3, parallel to the x-axis. Do you get it? Ken, Roshni, do you get it? Replacing x by 3x. It's not taking whatever that is inside, then times 3. It's replacing x by 3x. Yes, Harini, we can put any number here. Fx is equal to 3, fx is equal to 2, fx is equal to minus 5. Any number will do. Let me just read for you the solution for this that is given to you by SAJC, okay? SAJC says that fx is equal to k, where k is any constants. Where k is any real number. K is a constant where k is a real number. So they accept fx is equal to any real number. Okay, coming back to this, it is replacing x by 3x. Any question? Roshni, okay? Then C, it is a reflection in the x-axis. Reflection in the x-axis, positive x become, reflection about the x-axis, positive y become negative y become positive y. So it will be minus f 3x plus 2. Then next, it is a translation of 5 units in the positive y direction. So it is going to be this, 3x plus 2, the whole thing plus 5. And according to what the question says, this is a resulting equation. This gives us a resulting equation, gx. So I know minus f 3x plus 2 plus 5. This is equal to minus 3x plus 3 plus 1 over x minus 1. And instead of trying to reverse, we will continue to transform forward. Algebraically, what we can do is I can move 5 over to the other side. So just working on the same equation, moving 5 over to the other side. It is this, then minus 2 plus 1 over x minus 1. I'm going to multiply negative throughout. which will give me, for the same equation, 3x plus 2, then minus 1 over x minus 1. Okay? And I'm going to do a transformation now. I want to try to ultimately get an fx. So I'm going to replace x by 1 over 3x. And this is going to scale the graph by 3, by a factor of 3 parallel to the x-axis. But it doesn't matter, I'm going to just do an algebraic replacement. So I'm going to replace this x by 1 over 3x, then plus 2. Which means that I'm going to replace all the rest of the x by 1 over 3x. So 3, I'll replace by 1 over 3x plus 2 minus this x. I'm going to replace it by 1 over 3x minus 1. Let's try to do this together. So have your paper there. Okay, we are trying to write down the solution together. So on the left hand side here, we have a fx plus 2. It is the same equation. This is going to be equal to x plus 2 minus this. I think I can multiply by 3 in the numerator and the denominator. So it will be 3x minus 3. I will have this. I will continue to do my replacement. I'm going to replace x by x minus 2. So we have a f replacing this x by x minus 2, then plus 2, replacing this x by x minus 2, then plus 2 minus 3 over this. I'll replace it by x minus 2 minus 3. So now I'm going to be left with an fx. And this is equal to x. Then minus 3 over this, we have a x minus 5. It becomes a set of solution that is very, very repeatable for exam. And this is what we want to look out for. Something that is theoretically correct, something that shortens the time and increase the accuracy. Please remember this strategy and please try to apply it. Here, apply it in a revision package so that you know you can apply it again when it comes to your exam. Any question? Next, let's take a look at question number 4, solving an inequality. So question number 4 says, part 1 says, without using a calculator, solve the inequality. Without using a calculator, solve the inequality. We know what is the focus in this question. The focus of this question, as what we have discussed about 2 weeks ago, is not inequality. It's not just inequality. Because if it is just inequality, they would have allowed me to solve this using graph, because graph is the best possible way to solve this kind of inequality, right? So what is the intention of this question? The intention of this question is algebraic comparison and logical analysis. So I will be expecting to do that. My school has taken care of a large part of this because they gave us a template. An algebraic template that is very, very useful, but that template has a limitation. That template, to which I'm going to execute here, require your final manipulated inequality to satisfy 3 conditions. What are they? One side must be equal to 0. The other side must be multiples of linear expression. The third one. One side must be equal to 0. The other side must be multiples of factors. And each of them must be linear expression. 3 conditions must be satisfied. Will I be expecting all these 3 to be satisfied like very easily? No. That's what I will be expecting for an inequality question that is like this. I'll be expecting some obstacles along the way. And whenever I meet those obstacles, those are chances that we will need to apply our algebraic analysis. I'll need to apply our algebraic comparison and logical analysis. A very common way that this kind of challenges can appear that prevents you from very smoothly executing the entire strategy is to give you expressions that are always positive or always negative, and to give you repeated roots. So we have discussed about that. Please make sure that you rehearse that, or else you will just assume that it will always be so smooth sailing, right? You don't need to apply any analysis at all, which defeats the purpose of why inequality is even set this way. So let's see whether this is going to be the easier kind, which is those kind that you can just simply apply your school strategy with minimal analysis and you'll be able to get an answer, or it will be those kind that along the way something will happen and you're going to try to use your own strategy to remove whatever that stops you from achieving, because you have to achieve that ultimately, the three conditions. Okay, let's try. So we have this inequality. X squared plus 7x minus 17. This is divided by 2x minus 5. This is bigger or equal to 3. The first thing that I think I will want to do is to just shift everything over to the left-hand side. It is the easiest possible way to make one side to be equal to 0. So we have x squared plus 7x minus 17 divided by 2x minus 5 minus 3. This is bigger or equal to 0. I'm going to continue to try to achieve the three things. I've already achieved one. So for the left-hand side, I'm going to try to bring them together into one single fraction, and I'll try to factorize them as much as possible. So I have this plus 7x minus 17 minus 3, 2x minus 5. This is divided by 2x minus 5. This is bigger or equal to 0. And we will have x squared plus x minus 2 divided by 2x minus 5. This is bigger or equal to 0. The denominator is already linear. I'm not going to touch the denominator. I can factorize the numerator further, and it becomes x plus 2, x minus 1 divided by 2x minus 5. This is bigger or equal to 0. I guess things still seem pretty okay, right? We didn't see any glitches that comes along the way, and we have already satisfied all the three conditions so far. So once the three conditions are satisfied, I can draw my number line. The number line is going to be for x, and my number line will have three numbers. My number line will have minus 2, my number line will have 1, and my number line will have 5 over 2. I'm going to sub a number that is bigger than 5 over 2. 5 over 2 is 2.5. So for example, 3. 3, I'm going to sub it into the entire thing. It is going to be give me a positive result, so it's positive. I'm going to sub in something that is between 1 to 5 over 2. For example, 1.5. 1.5, if I were to sub it into here, I'm going to get a negative. 0 is in between here. If I were to sub 0 into here, I'm going to get a positive. Minus 3, if I were to sub it into here, I'm going to get a negative. What are we trying to look out for? We are trying to look for the set of values of x, such that this entire thing is bigger or equal to 0. So I know it is going to be this region of x and this region of x that causes this entire thing to be bigger or equal to 0. So my answer is x is going to be bigger or equal to minus 2, less than or equal to 1, or x is going to be bigger or equal to 5 over 2. But there's one analysis that this question requires. It's a very simple question, but one analysis. Usually when this kind of analysis appear in a question, it is outside that template. And where is it? It is here, right? It is here because I need to reject 5 over 2. Because if x is equal to 5 over 2, what will happen? Is it because it caused this to be undefined? Yes, it is, but this is not the key. Is it because it caused this to be undefined? Yes, it is. It will cause this to be undefined, but this is not the key. The key is in the original inequality. It is always in the original inequality that I find numbers that are supposed to be rejected, or numbers that didn't include, that was accidentally missed out here, and it is from the original inequality that I find numbers to pop up. So it is always the original inequality that is given to you by the question. This small little part is the analysis. Anything that is outside the template are situations which require you to do an algebraic comparison and logical analysis. Okay? And the question went on. This is part 1. Part 2. Part 2, we are supposed to solve for e to the power of minus 2x plus 7e to the power of minus x minus 17. This is going to be divided by 2e to the power of minus x minus 5. This is bigger or equal to 3. But let's see how this question is actually being asked. This question says, solve this inequality. Which means that this question is actually focusing on inequality, right? Because you are supposed to be able to use graph, seemingly so. Because they are leaving it to you to go and try to solve it. I will not try to solve this algebraically because there's this e to the power of minus x. I know by itself it's not going to give me any linear expressions already, so I'm not going to even try because this template only works if everything can be, the non-zero side can be multiples of linear expression. If it is not, it will not work. So I'll probably not do it algebraically, but at the same time, I definitely can see how this is going to be related to the previous part. So I'm going to use the previous part instead of drawing the graph. Especially, right, this question says leaving your answer in the exact form. If I were to draw it as a graph, I don't think I will get the exact forms. And can I just remind you guys, because I realized that J1 students, they sometimes will not be able to catch this exact form. It is one of the most common mistakes. I'm not sure why, okay, but it is really one of the most common mistakes that I have seen J1 students make, which is to give decimals when the question asks for the exact form. So we will not give it as decimal, let's remember. And for this case, I'm going to try to compare it to the previous one, which is actually very obvious, okay? Even without me saying, I believe most of you should have already been seeing that. So this is going to be e to the power of, let me just do a bit of manipulation. It is not difficult to see that x is going to be replaced by e to the power of minus x. Okay, but just let me do something a bit more algebraic to make it like as clear as possible. So this is this to the power of 2 plus 7. It is this again, then minus 17. This is going to be divided by 2, then e to the power of minus x again, minus 5, bigger or equal to 3. So I can see all the x is going to be replaced by e to the power of minus x, which means that from here, e to the power of minus x is going to be between minus 2 and 1, or e to the power of minus x is going to be strictly bigger than 5 over 2. I want you to read something for me, which is the solution from SAJC, part 2, this set of solution here. I want to weigh the pros and cons of this solution. In fact, I don't really like this set of solution that is given here. And I want to share with you why. But before that, can I just give you 30 seconds to a minute? Can you, this is correct so far, okay? Can you just read what SAJC had done? It is also correct. Okay, in fact, it is a good solution. But I think we can better this. 30 seconds, can you just give it a, can you just read it? What is the potential problem that you can see in this set of solution? Potential problem that may arise during the exam. I think this is fine. I think this is not too bad. Okay, e to the power of minus x is bigger than 5 over 2. If I were to ln both sides, then I get that minus x is bigger than ln 5 over 2. Then I move the negative 1 over to the other side, I get the answer. So I don't see much problem in this. I see more problem in trying to resolve this part here. When e to the power of minus x is between minus 2 and 1. Let me share with you the potential problem that I think you will face. And try to internalize this as much as possible. Number 1, this is handed to algebraically. For example, I need to choose whether I want to use and or whether I want to use or. This is not the most comfortable thing to do in the exam, especially when we are facing math and we are trying to put in our most basic English logic. It's not difficult. Okay, I'm not saying that it is not achievable, but it's something that I believe we can avoid. I'm going to show you how later. So obviously I'm going to use and because e to the power of minus x is between 0 and 1. and we don't change the definition of n and all from what we have read in a dictionary or how we have been using it since our nursery, since our pre-nursery. It is the same n, it is the same all. So if it has to be between 0 and 1, I will use the word n, and it must happen simultaneously. And when e to the power of minus x is bigger than 0, if you were to do these two algebraically, for example, you try to ln both sides, you know that the right hand side ln 0 is undefined. You press it into a calculator, ln 0 has no solution, which may give you the wrong impression that this is not going to give you any solution. So you may put NA, not applicable, instead of what the question put here, x belong to all real numbers. X belong to all real numbers is correct. Why? Because e to the power of minus x is positive all the time, regardless of x, which means that the values of x that satisfy this inequality are all values of x, because any values of x that I sub in is going to be bigger than 0. But when I press this into the calculator, I try to ln both sides. Ln 0 is undefined. But when I press it into the calculator, my calculator is not trying to work on inequality. My calculator is trying to work on equation. It's as if e to the power of minus x is equal to 0. Then you ln both sides. And obviously, ln 0 is going to be undefined, so the calculator will not give you any solution, because e to the power of minus x will not intersect the line y is equal to 0. And the problem is you're trying to handle this algebraically, and if you accidentally put this as not applicable, and this is an and relationship, not applicable, that means no solution, and solution, what is the overall? No solution. Because when it is and, it must be an overlapping region. Nothing overlaps what? Nothing to overlap. That's why the final answer should be no solution. That is why you cannot allow this to be no solution. This has to be all real numbers. All real numbers and this as the solution will give this as the solution. This is going to be the overlapping region. So there's too much analysis involved. And what I was telling you, analysis is good as a training. But if your plan is to solve an inequality, then you don't want to do so much analysis because it slows you down. And the challenge is huge because you're trying to analyze not just one or two numbers in equation, you're trying to analyze a lot of numbers in inequality. And that is why, according to what we have discussed in our conquest, what is the best way to solve this kind of question is to draw graph. You look at the way the question is being set. Did they actually tell you that you cannot draw graph? Did they actually tell you that you have to solve it algebraically? Did they tell you that you cannot solve this using a calculator? No. They just say that you want this in exact form. So what I would suggest that you do is you draw a graph. And the graph of this is very, very easy to sketch because if you have memorized if you have memorized enough of all the standard graphs, this is a standard graph, e to the power of x, e to the power of minus x. It is a standard graph. Let me sketch in the graph and you compare to the solution, okay? Let's see which one you think, both will lead you to the answer, but just be very honest with yourself, okay? Which one do you think will increase your chances of getting it correct during your mid-year? This or this? Let's see. What will happen if I were to draw a graph? If I were to draw a graph, even if I don't remember it, I can still depend on my GC. And I'll get a graph that is like this. It has a horizontal asymptote. A horizontal asymptote at y is equal to 0. This point here is 1. This is my graph of y is e to the power of minus x. Basically, what I do is I draw the graph of y is equal to e to the power of x. Then I reflect it about the y-axis because I replace x by minus x. Then we are trying to check whether this e to the power of minus x is between minus 2 and 1. Whether the y coordinate of this is between minus 2 and 1. 1 is here. This is y is equal to 1. Minus 2 is here. This is y is equal to minus 2. So what is the set of values of x such that the y coordinate of this is between 1 and between minus 2 and 1. It is this portion here. And it can be equal to 1. So I will take this. So if you were to look at this, I already know what is my answer. What is the x? X is bigger or equal to 0. x is bigger or equal to 0. It immediately gives me the same answer as this. I can even use this strategy, although it's not going to make such a big difference for this part, but I can use this strategy. So just to get ourselves more accustomed to drawing the graph, let's try it out for this. So for this, x-axis, y-axis, my graph tends towards the horizontal asymptote, y equal to 0. This is at 1. 5 over 2 is 2.5, so it's going to be here. Y is equal to 5 over 2. We are looking for the set of values of x such that the y coordinate is bigger than 5 over 2. So this is where the y coordinate is bigger than 5 over 2. So x must be this portion here, which means that I need this value for x. And I'm very safe because I'm looking at a specific value, which means that I can work on equation. So minus x is equal to ln 5 over 2. X is good. 5 over 2 is like ln minus ln 2 over 5. Right? Because this is like to the power of, I can bring the power, it's like 2 over 5 to the power minus 1, which I can bring it down. So this is like ln 2 over 5, which is a negative value. So this is ln 2 over 5. And I'm looking for this value of x that will cause this to be bigger than bigger than 5 over 2. So for this, therefore, I know x is supposed to be strictly less than ln 2 over 5. I'm really hoping that I have convinced you enough so that you can tell that drawing a graph for this has a higher chance of getting you correct in the exam as compared to doing this. Yes, it gives you a higher chance and it shortens the time that is taken. It's the best possible strategy. Do algebra if you feel like you are confident enough in getting it correct at a short time. But at any point in time when you're not confident enough, just revert back to drawing the graph for the second part at least. Okay? Next, question number 5. In question number 5, we are looking at functions. And in this function, it is trying to test us on two kinds of function. One is a piecewise function. A piecewise function is like any other function except that the function is going to be broken up into a few pieces. Most likely, different pieces of domain will give you different kinds of output. In this particular one, we have 2 pieces. Cambridge has given up to 3 pieces before. Schools I've seen it all the way until 4 pieces before. But it doesn't really matter, okay? You just react according to what the question says. It's very instructional for this kind of piecewise function. Which means that if I were to work on F3, for example, F3 is, 3 is between 2 to 4, so I'm going to put in 3 into here to replace x. F3 is this 8 plus a minus 2 times 3. Piecewise function. Next, this question also brings about another kind of function, which is periodic function. Periodic function is when the behavior of the function repeats after a while. Periodic function are functions that we have learned by memorizing it in our secondary school, which is sine function, cosine function, tangent function. We memorize it because we already know what are the period. Sine and cosine, the period is 2 pi. Tangent, the period is going to be equal to pi. So how do we deal with sine x? We deal with sine x by looking at it as if it is sine x plus 2 pi. Because every time when I plus 2 pi, it is actually going to be the same. In fact, we can extend this, right? It is not just going to be plus 2 pi, it can be plus or minus 2 pi. And it's not just going to be 2 pi, we can just plus or minus 2 pi multiple times, and I'm going to get back the same thing. So I can also extend this to sine of x plus 2k pi, where k are just integer values. Any question? This is how we have processed sine x. Or cosine x or tangent x is the same idea if we want to substitute numbers into it. And now in this question, what is the difference? It is still going to be a periodic function. It's just that the period is going to be given to us on the spot. And according to the question, fx is equal to fx plus 4. So what is the period? The period is 4. Right? The period is 4. And we can extend this, definitely. It is not just going to be 4, because every time when I plus minus 4, it's going to be the same thing. And it's not just plus minus 4, it can be multiples of plus minus 4. So I can also write this as f x plus 4k, where k are integer values. Please take note, when I write integer values, I don't mean positive integer, okay, because that's what some students misinterpreted it as. It is plus or minus integers, in general, integer values. Which means, what is F21? Here, what is F21? F21, am I able to find the value? I need my function in order for me to find the value of F21, right? If I were to look at my function here only receives things that are between 0 to 4, or at least what that is given to me is only receiving anything that is between 0 to 4. So F21 by right we cannot find. But because of the periodic nature of the function, we can take F21 and we keep minusing 4, minus 4, minus 4, minus 4, and you will end up with F1, right? Because 21 is like minus 4 5 times, 4 times 5, 20, and you're going to be left with just a F1. And what is F1? F1 we can evaluate because F1, 1 is between 0 to 2, so F1 is going to be 1 square plus A, F1 is going to be 1 plus A. And we have another one which is F39. 39, again I cannot substitute, I need something that is between 0 to 4. So 39, I'll minus 4, minus 4, minus 4, I'll minus 36 of them. 36 is 4 times 9. So I'll minus 36 of them, I'll minus 36 away from this, I'll minus 9 times of 4 from this, and I'll get a F3. 3 is between 0 to 4, so F3 is 8 plus A, then minus away 2 times of 3. This gives me a 2 plus A. And now I can find what is F21 plus F39. It is equal to 1 plus A plus 2 plus A. So when it comes to periodic function, we display our ability to manage periodic function by doing substitution, or at least that's the demand that is asked by the question. What other ways have we been tested when we were looking at periodic function in the secondary school? We have been tested in substituting numbers, right? We substitute angles. We substitute angles that are beyond 2 pi, that are less than 2 pi. What other ways are we tested? We are tested in sketching the graph of sine. And how do we sketch the graph of sine? You cannot possibly know everything about sine from, like minus 4 pi to 3 pi. What you will do is you will sketch one period first. You will sketch one period and then you extend it. You extend it to fulfill the entire domain that the question has given to you. So we're going to use the same experience also to try to sketch the graph of y is equal to fx from minus 3 all the way until 11. We will sketch for what we can sketch first. And according to what the question has given to me, I can sketch for one period from 0 to 4. 4 is the period. So I'm going to sketch this part first. Let's try sketch this together. So from 0 to 2, we are going to be sketching x squared plus 4. X-axis, y-axis. From 0 to 2, we are going to be sketching x squared plus, sorry, not x squared plus 4, x squared plus a. A, according to the question, a is a positive constant. Which, okay, I'm going to sketch using red color first, okay, because I'm going to be cutting it away. So if I were to just sketch x squared plus a, it is easy to sketch, right? It is just like x squared, which is a parabola, and then I will translate it by a units in a positive y direction. So I'll be getting something that is like this. This is my y is equal to x squared plus a. Okay, I will sketch this into my calculator. I don't like to use the piecewise function in my GC. I feel that it is actually more complicated. I find it's very unnecessary. Furthermore, it lacks details. And I got to do my normal, I just got to try to do everything from scratch again. So I feel that it's not worth it to use the, or at least for what it can provide for me so far, right? I don't find that it's very worth it. Okay, so I'm going to just sketch this as it is. Then I'm going to sketch the other one. This one is what? This one is a straight line. A is a constant, so this is a straight line. A straight line with a gradient of -2 and a y-intercept of 8 plus a. So that line, if you were to do a sketch of it, it is going to be something that is like this. And that is going to be from 2 to 4. So you need to find details about this, okay? So the detail will definitely be when x is equal to 0. When x is equal to 0, you're going to sub into here. I'm going to get an a, so it is going to be at this point here. And this point here is at 0a. Then when it goes to 2, we're going to end at a point. That point is going to be 2 squared plus a, so it's going to be 4a. And when I sub 2 into here, I'm going to get an 8 plus a minus 4. So I'm going to also get a 4a. So they share the same output when 2 is sub into here, when 2 is sub into here. So at 2, it is actually the place where they intersect. So this happened, and it happens at 4 plus a. This happens at a. And when x is equal to 4, if I were to sub it into here, I will have a 8 plus a minus 8, which is a. So a is already here. So it is going to be this. Which means that my graph is this. Here. Here. Let me erase this. Let me erase this. Here, I will also erase. I will sketch one period first. Then I will continue with the rest. But let me top up our description by looking at some finer details before we continue to extend to the right, extend it to the left. If you were to just look at 0 to 2, if you were to look at the domain, it is strictly bigger than 0, it is less than or equal to 2. Which means that this portion here, if I can just take it out and redraw it, it is supposed to be strictly bigger than 0, it's supposed to be a hollow dot, it is supposed to be less than or equal to 2. So it is supposed to be a solid dot here. As for this linear line, according to the question, it is supposed to be strictly bigger than 2. It is supposed to be less than or equal to 4. So it is supposed to be a hollow dot here. It is supposed to be a solid dot here. So what should I do, especially at this point? Here I can still put a hollow dot. Here I can still put a solid dot. But here is where the solid dot intersect the hollow dot. What should I do? When solid dot intersect a hollow dot at exactly the same place, it becomes a solid dot because it has to have output. And the output is 4 plus a. If we were to put a hollow dot here, it means that when x is equal to 2, the function is undefined. If you were to look at the question, when x is equal to 2, is it undefined? No, it is 4 squared plus a. So this solid dot intersect the hollow dot will become a solid dot. And do you need to put in a solid dot? No. If the solid dot appears within the graph, not as an endpoint, you don't need to put anything. Because solid dot means there's an output and an endpoint. And if you're going to put solid dot here, that means you've got to put a lot of solid dots, solid dot all the way, right? Because it is together with the graph, it is in between the two endpoints. So I don't need to put anything here, okay? This is fine. If I want to put something, I should put a hollow dot here, I should put a solid dot here. But later we are going to continue. And it will once again be like the same situation. The hollow dot will be intersecting with a solid dot, so I will take it. This solid dot will intersect with a hollow dot, so I will take it as a solid dot. Okay? Any question? Let's continue towards the right, because we are supposed to sketch all the way until 11. So I'm going to extend it by another period, which will go to 8, and I'm still not reaching 11, so that's fine. I'm going to continue. From here, I'm going to curve up. So from here, we'll do a curve back up to 6. And I will continue to let it come down to 8. Another period. I'm going to continue to 10. So this part will go up. And this time, instead of going all the way until 12, we're going to stop at 11. So by right, it is supposed to come all the way down to 12. Okay, but we're going to stop at 11, which means that now it is going to be coming down all the way until here at 11. And according to the question, it is less than or equal to 11. So this here is supposed to be a solid dot. This portion will disappear. And for all endpoints, you need to label it as much as possible, which means that we need to find out what is F11, right? From here, we need to find out what is F11. F11 minus 4 minus 4 minus 4 minus 8, it will be F3. And F3 is, just now we have found out, F3 is going to be 2 plus A. 2 plus A. So I know this point here is going to be 11, 2 plus A. And then we're going to extend it towards the left. Towards the left. We're going to extend it towards the left all the way until minus 3. This portion will be replicated here to minus 2. So from here, this portion will be replicated to here, and that will actually end at minus 4. So by right, I'm supposed to have this part. But I know that I need to end at minus 3. So minus 3, if I were to extend this part up, and it is supposed to be bigger or equal to minus 3. So I have a solid dot here. It has to be this. Which means that I will also need to know what is F minus 3, which is F1. Because plus 4, it gives me, minus 3 plus 4, it gives me 1, F1. And F1 is 1 plus A, which means that this point here is minus 3, 1 plus A. And this will be my graph of y is equal to fx. I think I better make sure that this point is a bit higher up. Okay, I don't want the examiner to have any doubt that it is going to be at this, it is going to be the same y coordinate as A. What do we expect when we are drawing this graph? What do we expect? We expect ourselves to be slowed down. Can you see? Yeah, even for me, when I draw this, it is not the most familiar graph. And furthermore, I have to draw parts of the graph that is like this. And then, like, just drawing wise, it's not easy to draw. So I need you to have this kind of expectation also, that when you're doing your mid-year paper, you don't expect yourself to be, doing the same pace. Because many times when we are talking to seniors, talking to some people, they may give you this impression that you are supposed to calculate like what kind of speed do you want to run the entire route. You are going to maintain at the same speed. So for example, every 1 mark that is in H2 math, you are supposed to do it at 1.5 minutes. For example, these are not accurate. Okay, I mean, even if that person who told you is really sticking to this, I can tell you that person is probably not doing so well in the full paper. You're supposed to vary your speed. You're supposed to do a paper at different pace. You're supposed to expect that there are some parts that will slow you down, and there are some parts which you can quicken up. You want to train yourself to quicken up. So this is supposed to be done slower, and you want to be comfortable with it. You definitely need to practice, because if you can increase the speed to drawing this, that will be the best for you, okay? But what I can expect is, from the previous question all the way until now, 3A, I will probably slow down a little bit, because 3A is not very common, and I need to have a bit of creativity. 3B, is something that I'm going to do absolutely fast. It is in my conquest. There's not much changes to the style of the question, so I can do it fast. In fact, I can do it very, very fast. Then after that, if I were to progress to for part 1, okay, I just want to make sure that I'm careful. In case I need to do some algebraic analysis, I know I have to do that, or else I'll just keep trying to press on to see whether I can fulfill the 3 conditions, and I could. It will be done fast. For part 2, it will also be done fast, provided that you remember that we can actually solve it using graph. Then I don't need to worry about this thing, that I need to analyze. So it gives me a lot of time now to do 5. I'm pacing myself by varying the paces, by varying the pace at different stage in my paper. Let's look at another functions question, question number 6. Any question? I'm going to erase this. We are given 2 functions. Let me write down the 2 functions on the board for my pointing. So, sorry, I really want to laugh at I mean, I'm writing down this is really purely for my pointing. Because sometimes I will feel very, it just feels very weird, okay, that I'm trying to write on the board and actually I have a digital pointer there. So sometimes I thought I would want to point, like actually point to that. And sometimes when I think about my board, I thought I will use my cursor to point here, so the whole thing is just very weird. But anyway, it's me. This is going to be ln of x plus 1 squared plus 4, where x are all real numbers, x is strictly bigger than minus 5. Then I have g, which is given to me as x squared minus 4. This is easy. X is just all real numbers. Part 1. Part 1, we want to show that fg exists. We want to show that fg exists. We are going to make use of the same schematic as what we have, as how we have discussed it. So fg is x first going into g, then it will go into f, then it will come out from f. So for fg to exist, it is about the place where they are connected together. So we want to make sure that the output of g must all be accepted by the domain of f. And we want to check whether this happens. The domain of f is strictly bigger than minus 5, and this is fine. How about the range of g? The range of g I don't have, and how am I supposed to find the range of g? I sketch the graph. Why do I want to sketch the graph? Because the domain are all real numbers. Because the domain is a continuous set of numbers. And this is regardless of whether I'm expecting there to be a maximum point or minimum point, it doesn't matter. As long as my domain is a continuous set of numbers, I know graph is my best possible tool. So I'm going to try to sketch the graph of g, and this is an easy graph to sketch. I don't even think I need my GC. It is just a parabola again, but being translated by 4 units in the negative y direction. So g is going to look something that is like this. Symmetrical about the y axis. The minimum possible point here is 0, minus 4. This is minus 2, 0. This is going to be 2, 0. This is the graph of y is equal to gx. So to code this, I need to code also the numbers. And what is the range of g? The range of g is going to be from minus 4 all the way until infinity. Minus 4 all the way until infinity. This is going to be the range of g. And what is the domain of f? The domain of f is from minus 5, but not inclusive of minus 5 all the way until infinity. All the numbers here can go into minus 5 to infinity, so this is going to be a subset. Therefore, the composite function fg exists. I want to find the expression for fg. This is find fgx is by trying to put the entirety of this into this. So we have a ln of x squared minus 4 plus 1 square, then plus 4. So we have fg as ln of, this is going to be x squared minus 3 square plus 4. And we also want to quote the domain of fg. The domain of fg depends on what that can go into the composite function. And it is restricted by this part here, the domain of g. So what is the largest set of values that can go into the composite function, which is going to give us the domain of fg? It is going to be the same as the domain of g. So this is like the domain of g, and the domain of g is all real numbers from minus infinity to infinity. This question is very weird. This question is weird. Why is this question weird? Because, right, this question asks you, can you find the exact range of fg? They're asking you to find the exact range of fg. And I believe that unless you are someone, and you need to become this person, okay? Unless you are someone who doesn't mind doing some experimentation, like smart experimentation and trial and error, this is really what H2 Math is trying to build you into, okay? That means in a situation where you don't have all the information, are you still able to navigate through it? Despite some challenges here and there, despite not giving the full set of instruction of where you're supposed to walk, are you still able to navigate through this kind of situation? Let me show you what I mean. If you were to look at this question very carefully, this question requires this kind of student. Because for the way that this question has been constructed, it just seems like we are going to use method number 1 to find the range. Method number 1 means we are going to look at the entire function, the entire composite function, together with its domain, and I'm going to draw the graph, and I'll treat it as if it is one single function by itself. Then from there, I'm going to try to find the range of the composite function. It's not going to work. Okay, I'm going to show you why it's not going to work. But in the exam, right, that is what I will do, you know. I will seriously, very honestly, I will try method number 1 first. Because of the way this question is being set. Which means that I'm going to prepare to draw the graph of y is equal to f, g, x. The domain is all real numbers. I'm going to press this into the calculator. You don't have to press into the calculator, but let me show you what is the graph that I'm going to be getting. The graph that I'll get is this. I'll be getting this graph. So looking at this graph, you know that the range is going to be from here all the way until infinity. You will check the minimum point, the y coordinate of the two minimum points, just in case one is lower than the other. I have checked it myself, and this is minus 1.7321, 1.3863, and this is 1.7321, 1.3863. They share the same y coordinate, so this is the minimum possible already, which means that if you were to use method number 1, what is the range of the composite function fg? It is going to be from 1.3863 all the way until infinity, and you are not going to be getting marks for it. How many marks are we going to be expecting for this? This whole part is 5 marks. Show that fg exists. Minimum, let's say we give it 1 mark. They want the expression for this. Minimum 1 mark. They want the domain, minimum 1 mark. So I've gotten myself 3 marks, which means that this is probably going to be 2 marks, because the previous few parts are not very difficult, right? So I'll probably be losing 2 marks for this. I can tell you 2 marks for media is fine, but 2 marks for prelim is very different. 2 marks for prelim can mean whether you're going to be promoted or not promoted. Okay, let's not jinx ourselves, but 2 marks is very important for prelim. And this is not going to give us 2 marks. This is probably going to give us no marks. Maybe 1 mark, okay, maybe 1 mark, because we do get the answer. But what is the problem with my answer? The problem is the question asks for the exact range. And it's not possible for me to get an exact range if I were to sketch the graph of y is equal to fg. Which means you don't need to mind about this so much. You just want to try other options. And there's only one other option. The problem is if you don't even try the option. So I need you to do this together with me, okay? I need you to be a student who doesn't mind, who doesn't mind trying a little bit of this, trying a little bit of that, provided that your foundation is good. you're not trying because you don't have anything to try. It's like you're not trying because you don't know anything, so you just anyhow try. Okay, we're not talking about someone who is anyhow trying. I'm talking about someone who knows the option. I'm talking about someone who knows what are the possible good things to put there so that I can do some actual experimentation, and I need to do this experimentation fast. And I'm going to go for method number 2. Let's see whether it is going to work. One of them should work. They cannot possibly set a question that is a trap and you're going to die in that question. So let's try method number 2. Method number 2 focuses on the last function, which is f. Method number 2 focuses on f. And I know what is the domain of f. The domain of f stated that it is going to be from -5 all the way until infinity. Which means that if I were to put -5 all the way until infinity into the function, I'm going to get a particular output. Let's see what is the output. Can I try to sketch this? Let me try to sketch, okay? I've already sketched it on my calculator, and let me share with you the graph of f. X-axis, y-axis. The graph of f looks like this. This is at -5 all the way until infinity. This here is at ln 5. Ln 5 because if you were to just look at the expression here, when x is equal to 0, we have a ln 1 plus 4. That's why I get a ln 5. So a ln 5 is not obtained by my calculator. As for this point here, I will get a -1 and 1.3863. -1 and 1.3863. This is for f as a full function. But I know when f is being connected to g, the difference is what that goes into f is what comes out from g. So what that goes in is not going to be from -5 to infinity. What that goes in is going to be what that comes out from g, which is from -4 all the way until infinity. So I'm going for -4 all the way until infinity. This is -5, here is -1, so -4 should be somewhere here. And it's inclusive of -4, so it's going to be -4 all the way until infinity for x. -4 all the way until infinity. So from this black colored portion of the graph, that is where we are going to see what is the range of the composite function f, g. Can you see what is the difference between this 1.3863 and this 1.3863? What is the difference? The difference is the x-coordinate. The x-coordinate of this is still going to be this kind of number, but the x-coordinate of this is -1. This is a nice number. This is -1. So if I were to put -1 into here, I will have a -1 plus 1, it is 0. So I will have a ln 4, which means that now I know what is this number. It is no longer going to be just 1.3863 as an approximated number. It is exactly ln 4. Which means that the range of the composite function is going to be from ln 4 all the way until infinity. I have a ln 4 to infinity. It's a very, very interesting question, and you will not be able to experience this if you were to just simply look at the solution. And that is why I have protected the solution from you printing it. Because one thing that I feel, okay, one thing that students should do but they don't do is that when they are doing practices, when they are doing exam papers, they should refer as much as possible, but they don't do. They don't refer. That means they will just try a question, and if they cannot get it right, what they will do is they will just either get stuck. They will spend hours staring at the question. You're just hoping that the more you stare at it, somehow the solution will pop up. Just refer, you just refer a bit, you look at the theory, you look at the practice, you look at some examples, you look at our conquest, maybe you can get the question done. So one thing that you must do during this holiday is please have your outline, have your conquest with you, regardless of whether it is tuition or not, just keep referring and referring and referring. Number 1, I want you to refer. Number 2, I don't want you to refer to the solution too much. I mean, in the end, you can still take a look at the solution, you can still get some inspiration from the solution, but don't do it too much. Why? Because the solution tend to hide details. The solution tend to give you instruction when it is not supposed to be instructional based on the question. So looking at the solution actually cause students to still not be able to do that in exam. They will just have this misperception that they can do because they understand the solution. But they didn't know that they have missed out detail that is like this, because the solution only gave this, The solution didn't tell you that if you were to do it this way, it is not going to work. So you didn't know that you got to do try and error. You just expect that, oh, okay. You don't even know that this ln 4 was actually not ln 4 when you press it to the calculator. You just expect that, oh, it is just going to be ln 4. Fine. I'll just produce this as my answer. So the moment when you miss this, in the exam, you're going to miss it big time also. And what if this is going to be used in the next part? So that's how marks get tumbled down and down and down and down. So don't look at the solution too much. Don't ask people too much. Give yourself a chance. You can do it. Just tell yourself, I mean, if you cannot just still look at the solution, ask people, that is fine. But first, seek from your outline, seek the inspiration from your conquest. Give a reason why F does not have an inverse. This question is strange because I find it strange because they actually gave 2 marks. Okay, they shouldn't be giving so many marks. They should have just given 1 mark to this. I'm not sure why, but sometimes teachers plan according to the entire paper. So I'm going to be making use of the graph of F. Since I'm doing that, I'm going to just redraw it here, okay? So let me just very quickly redraw this graph, the graph of fx. So it is like this. And here we have a -5, 0. And here, this is ln 5. And here is -1 and ln 4. This is my graph of y is equal to fx. Y-axis, x-axis. So this question says, give a reason why f inverse does not exist. Based on the graph, I guess it is obvious, because I can find a horizontal line that cuts it at more than 1 point. And like what I was telling you, since the question is asking you to check whether f inverse does not exist, so you can give a counter example. You don't need to state a lot of different horizontal line, but you just need to state one possible horizontal line. One horizontal line that can cut it at more than 2 points is fine. So looking at this, I think one easy horizontal line is y is equal to ln 5. So I'm going to just quote that. I'll say something that is like this. Since the line y is equal to ln 5, cuts the graph of y is equal to fx at 2 points or at more than 1 point. Therefore, f is not a one-to-one function. This implies that f does not have an inverse. And if f has an inverse, what is the smallest possible? So if f has an inverse and the domain is going to be restricted to x is bigger than k, what is the least possible value of k? So x must be bigger than k and the graph must pass a horizontal line test. K can be here, k can be here, k can be here. The least possible k can go is -1. That means, so what is the least possible value of k? The least possible k is equal to -1. This is in part 3. And part 4. Part 4 is, again, very, very interesting. Part 4. Using the value of k found that is in part 3. So I'm going to be using this k, which is equal to -1, which means that we will be working on this. Fx is equal to ln of x plus 1 squared plus 4, where x is supposed to be bigger than k, so bigger than -1, which means that we will be looking at this graph here. We'll be using this graph here. 3 marks. Find the exact range of the values of x such that f inverse x is less than or equal to 0. I want to find the exact range of values, such that f inverse x is less than or equal to 0. We are supposed to solve this. F inverse x is less than or equal to 0. Let's discuss the challenges that we are seeing in this question. Okay, now first of all, we are supposed to quote the exact range of values, Secondly, what kind of question is this? Of course, it is within function, so it's still a function question. Of course, there's an f inverse, so it is an inverse function question. But this is an inequality question. Okay, this is an inequality question. I'm going to give you some hint, and I want you to give me some feedback of how you think we can very efficiently solve for this. Because one way that we can do, which is not efficient, and we don't even know whether it is going to work. One way that we can go about doing this is to actually find the expression for f inverse. Because I can just let y be equal to this, then make x the subject. So we can find the expression for f inverse. If I can find the expression for f inverse, that means I can sub it in to try to solve this inequality. Let me just tell you first, it is not efficient enough. And you may not even get it to work because the question asks you for the exact solution. What if you get all the decimals? So you want the exact solutions. So if let's say we have already processed this, okay, and we know that yes, we can find the expression for f inverse. It is a possibility, but I'm going to keep that as a backup. Is there any other way that you can think of and share that with me, such that I can solve this more efficiently? Anyone? Any suggestion? Oh, okay. Sorry, just now I wrote wrongly, is it? It is supposed to be from -5 to infinity. Okay, so I wrote wrongly. Okay, it is -5 to infinity, not -5 to 0. That's my mistake. Harini is pointing out to me, it should be to... It's here? This graph is correct. It was the graph that was previous, the diagram that I drew just now, right? The fx graph. So I think I wrote -5 to 0 or something. Left coordinate. This is the coordinate. So -5 and this is -5 and 3. This is my mistake. This is -5 and 3. Okay, can you share with me? What other strategies can you think of in order for me to try to solve this? Anyone can think of a strategy if you don't want to find the expression for f inverse? Is there any way that you can solve for this? Try to think about our inverse function. Let me just show you, okay, in our outline. Let's try to see whether we can find some inspiration from our outline. So let me show you the functions part. Inverse function. Is there something that I can use in my outline? Because I was already saying we try not to use this. That means trying to find the definition for f inverse. Is there something else that we can use from our outline that can probably prompt us to solve this more efficiently? Anyone, any suggestion?
The domain.
The domain?
Yeah, like domain range.
Domain range? That means you're going to use this?
Yeah.
Okay, how do you think we can use domain range to solve this?
Like, for the range for
No, wait. The range is range of fx. The range of, that means the output of this must be less than or equal to 0. The output of this, okay.
Therefore, is less than or equal to 0.
Wow, Shijie, your understanding is superb. Okay, Shijie is saying, why not we try to see this as this instead? Because this is actually the output of this graph. right? That means this is actually the y of this graph. So we are trying to say that the y of this graph is, this is actually the x of this graph, right? Because this is the output. So I want to make sure that the x of this graph is less than 0. Then I can find out what is this part. Because this part is F inverse. Just in case this is confusing, okay, just in case this is confusing, I mean, Shijie said it, that means I assume that Shijie can see it very clearly. Just in case this is confusing, let me try to present it to you from another perspective. Maybe it is going to be easier, okay? Which is what we can do from what we have here is to make use of the relationship between F and F inverse. Because we have said it before, right? It is always going to be the relationship between the two. Between F and F inverse. The relationship between F and F inverse. So we want to look for a relationship when we are doing this kind of question. We don't want to focus on just the function itself. So the relationship that we can make use of is actually this. The graph of F and F inverse. Because in my calculator, I should have already y1. And y1 is this ln x plus 1 squared plus 4. I should have this. And I encourage you to draw in y2 as x. So what you will be having in your calculator so far is going to give you these two things. Number one is this. Y is equal to x, which is from your y2. The other one is this graph, and I'm going to just draw it for fx, which is strictly bigger than -1. So it is going to be here. The graph is going to be like this. Okay? And this point here is -1 and ln 4. This point here is 0 and ln 5. So what I'm going to do is, I will just base on this. I will not use my calculator anymore. I will just base on this, I'm going to sketch the graph of y is equal to fx. So this point is going to become somewhere here, let's say, and the coordinate will be ln 4 and -1. And the tangent is going to be horizontal. That means the tangent is going to be vertical. So it's going to be this. And you will curve back up. And I'll just be careful, I don't want to accidentally curve it back, or else you will fail the vertical line test, then it's not going to exist as a function. So I curve it this way. This is my graph of y is equal to f inverse x. And I know what this point is. This point is ln 5 and a 0. And this is perfect. Because like what Shijie has seen here, we are seeing it in this graph. And we are trying to find the values of x such that the y-coordinate of this graph is less than or equal to 0, which is this portion. The y-coordinate is less than or equal to 0. So for the y-coordinate to be less than or equal to 0, what is the corresponding x values? It's going to be this portion here, right? So looking at this, I know x is going to be strictly bigger than ln 4. It's going to be less than or equal to ln 5. Shijie, from what you have mentioned to me just now about how you see this, it is going to be from ln 4 to ln 5, like this, right, Shijie?
Yeah. Like that.
Hey, very good, Shijie. Superb. Bad. Okay, you display such presentation.
Yeah.
Okay.
But the values are correct.
Oh, you mean the bigger or equal to you wrote wrongly, is it?
No. But presented in grade. I don't know why I did it. Yeah, but the values are both ln 4 and ln 5.
Okay. But very good, okay, very good, Shijie. Impressive. And for those of you who actually saw the same thing, very good. I'm very happy for you because number one, you use graph. Number two, you really understand what is this f and f inverse, and you process it, and your ability to process is giving you a lot of advantage already. Okay, so superb, okay, for whoever managed to think about this also. And this is going to give you 3 marks. They are very, very generous, but they also know that this is not easy. Let's take a quick look at 7, and if we manage to finish 7, if there were to be some time, maybe we can take a look at 8. If not, we will stop at question number 7, okay? So in question number 7, part 1, we are given this hx. This is equal to a plus b minus x. This is divided by x minus c square. A, B, C, they are constants, and we are supposed to find A, B, C. We are given features of the graph. We are told that there are two asymptotes. Horizontal asymptote y is equal to -1, vertical asymptote x is equal to 2. And let's not forget about the definition of the asymptotes. I was telling you how important it is because that is how we process all horizontal or vertical asymptote. What is a horizontal asymptote's definition in general? It is the behavior of y when x tends to plus or minus infinity. So we are seeing this behavior here when x tends to plus or minus infinity, y tends to -1. When x tends to plus or minus infinity, hx tends to a. So we know a is going to be equal to -1. Vertical asymptote is the value of x that causes y to be undefined, which means that when I sub 2 into the denominator, it should be equal to 0 because it is going to cause the whole thing to be undefined. It is the value of x that causes the whole thing to be undefined. This tells me what c is. C is equal to 2, which means that hx is equal to -1 plus b minus x divided by x minus 2 square. We will still need to solve for b, and I think this is easy because actually the graph passes through 3 points, and I will just sub one of the points inside. I mean, the easiest point is 0, 0. So h0 will give me an output of 0. So -1 plus b minus 0 divided by 0 minus 2 squared. This is equal to 0. This helps me to find b. b is equal to 4. It should be 3 marks because one mark each. Wow, they give 4 marks. Superb. Super easy to score 4 marks. And next, the graph of kx is given to me, and we want to try to describe a sequence of 2 transformations that will transform the graph from hx to kx. Let's rewrite hx. hx is -1 plus 4 minus x divided by x minus 2 squared. And this is supposed to be transformed to -1 plus x plus 3 divided by x plus 1 squared. So we are, sorry, this is transformed to this, which is kx. So what we are supposed to do now is to do translation, scaling, reflection. And we have mentioned before in our conquest, therefore translation, scaling, reflection. For translation, scaling, reflection, they need not be asking me just about sketching because it can be described, which we are seeing here. So we have a few variations of translation, scaling, reflection that we saw in our conquest. One is when they give you the transform graph, then you deduce the original graph. The other kind is going to be this kind, where you are supposed to describe the transformation. And of course, we also have this, which we have done in question number 3 just now. And when it comes to this kind where you're supposed to do description instead of sketching, what you will be expecting yourself to experience is improvisation again. And it is usually going to be those kind of self-initiated improvisation, which means that if you are looking at, for example, this question that is from our conquest, we are supposed to transform it from 1 over x to this. And if you are just someone who, don't do experimentation, cannot do trial and error, you are just very into just do whatever that the question tells you and you don't change anything, then I doubt you will be able to do this question correctly. But if you don't mind doing a little bit of experimentation, try and error a little bit, so you can see that, hey, if I were to go from 1 over x to 2x plus a over x minus a, is sort of tough. But it doesn't mean that I need to subject myself to just 1 over x, or I need to subject myself to 2x plus a over x minus a. I can always do a bit of manipulation to the expression and see whether it is going to become easier by changing it from this form to this form through long division, trying to express it from an improper fraction to a proper fraction. I found it so much easier. So this is what you are going to be expected when you are doing your algebra, when you are doing, for example, this kind of question. So you should ask yourself, Should I do any transformation? Sorry, should I do any improvisation to the algebra? I don't think so. For this particular question, I don't think so. Because if you were to look at this and this, -1, and it's already something that is very similar. So I don't think I want to manipulate it further. I initiate not to do any further improvisation. But I don't think this question is actually that easy. Furthermore, the question restricts you to just describing two transformations. So I'm going to just write down my solution on the board, but I don't think it is going to be a fair portrayal of how this question is going to be done by yourself in an exam. Most likely you need to do a little bit of testing here and there. So I'm eliminating the testing, which is similar to how you will be lacking in terms of what you're supposed to be trained for if you're to look at the solution too fast. So I'm showing you the solution, but I'm at the same time trying to warn you that my solution is not a good solution because I just tell you, I give you information that you're not supposed to have on hand when you're doing this question. So I'm going to just show you, okay? What I think I want to do is I'm going to start with this definitely. So it is going to be this -1 plus 4 minus x over x minus 2 squared. Am I supposed to start with this? Yes. So from here, I'm going to try to transform it to this. I don't think I will take the whole thing then minus something or times something, because this -1, in fact, I'm going to keep. This plus, I'm also going to keep. So I'll most likely try to replace x. And I think what I want to do to replace x is, I want to make sure that x can become a positive coefficient first. So to do that, my plan is to replace x by minus x. I'm going to try out this. So minus x minus 2 square. Equation-wise, expression-wise, it is going to be plus. Here I will have a 4 plus x divided by minus square is going to become positive. So I can write the denominator as x plus 2 square. We again need this kind of small little improvisation. And I want the x plus 2 square instead of the minus x minus 2 square, because here is positive, positive. And this makes it easier for me to see already, because from here, I just need to do another transformation, another replacement. I just need to replace x by x minus 1. So if I were to do that, it will be here x minus 1 divided by x minus 1 plus 2 square, which will give me a minus 1 plus x plus 3 over x plus 1 square. So I did two transformations, replacing x by minus x, and then I replace x by x minus 1. So the true transformation will be replacing x by minus x. Positive x become minus x become positive x. So it is going to be a reflection about the y-axis. The second transformation, replacing x by x minus 1, it is going to be a translation. And like what I have shared with you, please use